In the second part of section 3.3, we're going to continue with evaluating limits, and we're going to look at another strategy. So recall in the first section, we had our first strategy, which was direct substitution. Our second strategy was if we use direct substitution and got a number over 0, then where they were asking us to calculate our limit was a vertical asymptote, so we have to use a sign chart. Now we're going to look at some other strategies. So first of all, in question A, I'm going to use direct substitution, and if I use direct substitution, I'm going to get 6 squared minus 7 times 6 plus 6 over 6 squared minus 36. This is going to result in 0 over 0. So when I get 0 over 0, it's indeterminate. So I can't use a sign chart, so I have to look for another strategy. Okay, well, as you can see in the title of this section, one of our first strategies we could do is factoring. So I am going to factor my numerator. If I factor the numerator, I get x minus 6, x minus 1. And if I factor the bottom, I get x minus 6 and x plus 6. Now this factor here of x minus 6 is the one that's causing me not to be able to use direct substitution, because that's resulting in a 0 in the denominator. But notice I have an x minus 6 here and an x minus 6 here, so I can cross those out. And I'll be left with the limit as x approaches 6 of x minus 1 over x plus 6. And now I can use direct substitution. And this results in a limit of 5 over 12. All right, in our next example, again, if I use direct substitution, I'm going to get 2 cubed, which is 8 minus 8, which is 0. 2 squared is 4, plus 2 is 6. Negative 3 times 2 is 6. I'm also going to get 0. So direct substitution does not work. It's not a vertical asymptote, so I must look for another strategy. And again, we are in the factoring mode. So it's going to be the limit as x approaches 2. And if I factor the top, it's a difference of cubes. So it's x minus 2, x squared plus 2x plus 4. And in the bottom, I get x minus 2 and x minus, whoops, not 2, but x minus 1. Now, it's this factor right here that is not allowing me to use direct substitution, because I get 0 in that term if I put 2 in. Notice x minus 2 cancels out. So I'm left with the limit as x approaches 2 of x squared plus 2x plus 4 over x minus 1. Now I can direct substitute. So 2 squared plus 2 times 2 plus 4 all over 2 minus 1. And if you work that all out, I'm just going to put the answer up here. It works out to 12. Okay, sometimes we have to simplify in order to get our desired limit. So first of all, if I use direct substitution, I get 2 squared, which is 4 minus 4 is 0, and 0 in the bottom, I get 0, so direct substitution won't work. So if I look at what kind of algebra I can do with this, one thing I can do is I can expand this by squaring the binomial. And that's what you get when you square the binomial. And I end up with an expression that looks like that. So now, if I collect like terms, 4's are going to cancel, and I'm left with h squared plus 4h over h. Somehow I have to get rid of that h in the denominator because I'm not allowed to substitute, because I'll get 0 in the bottom. Well, I can factor an h out of the numerator to get h plus 4 over h. And now my h's cancel. And now I can use direct substitution with what's left. If I put a 0 in for h, I get 0 plus 4, which is going to be 4. In our next example, again, if I use direct substitution, I get a third minus a third, which is 0, and 2 times 0 is 0. I get 0 over 0, so I have to do a little bit of algebra here again. Well, in the top, I'm subtracting fractions, so I need to get a common denominator. So I'm going to multiply this side by x plus 3. X plus 3, and this side by 3 over 3. So this is going to be the limit as h approaches 0. If I multiply 3 times 1, I get 3. And my denominator, I'm just going to leave it as 3 times x plus 3. Just leave it in factored form. Minus 1 times x plus 3 is x plus 3. And again, make sure you put brackets because this negative sign has to distribute to both terms. And there I have 3 times x plus 3. And this is still all divided by 2x. Now I can combine these two terms because I have a common denominator. So this is going to be the limit as h approaches 0. So I'm going to have 3. If I distribute, that's going to be minus x minus 3 over 3 times x plus 3. And this is still all divided by 2x. So this is going to equal the limit as h approaches 0. Here, this 3 will cancel out with this 3. So I'm left with negative x over 3 times x plus 3. And this is still all over 2x. So now this 2x is really over 1. So I have a fraction. You can consider it as a fraction over a fraction. And if you're dividing fractions, you have to multiply by the reciprocal of the denominator. So this is going to equal the limit as h approaches 0. I have negative x over 3 times x plus 3. If I take that and multiply it by the reciprocal of the denominator, I'm going to get 1 over 2x. Okay, and this should have been as x approaches 0. I apologize, not h. Okay, so now notice the value down here that's not letting me substitute is this value of x right here. So somehow I have to eliminate that. Well, if we take a quick look, we will see that this x will cancel out with this x. I'll be left with the limit as x approaches 0 of negative 1 over 3 times x plus 3 times 2. And now I can substitute 0 in, and I'm going to get negative 1 over 3 times 0 plus 3 times 2. So this is going to be negative 1 over 18. So again, even though we had an expression at the very beginning there that was somewhat complicated, we just used our algebra skills until we could eliminate this variable of x in the denominator. Okay, the last strategy we're going to learn today is learning how to rationalize. Okay, now back when you were dealing with radicals in pre-calc 20, if you had 7 over, say, 2 minus root 3, and you were dividing radicals, to get rid of your radical in the bottom, multiply by the conjugate. And the conjugate was the same terms with the opposite sign. So if I multiply on top, 7 times 2 is 14, and 7 times root 3 would be 7 root 3. If I FOIL out my conjugates, 2 times 2 is going to be 4. My middle terms are going to cancel when I FOIL these out, and negative root 3 times positive root 3 is going to be negative root 9, which is really 3. So therefore, 4 minus 3 is 1, and my final answer would be 14 plus 7 root 3. And now I've eliminated my radical in my denominator, which we always want to do with radicals. We're going to use a similar strategy here for this question. If I use direct substitution off the start, I get 0 over 0. So I am going to this time multiply by the conjugate. And the conjugate of the numerator would be root x plus 1 plus 1 over root x plus 1 plus 1. And so this part here is really just a form of 1. So now I'm going to multiply out my conjugates. And root x plus 1 times root x plus 1 is just going to be x plus 1. When I multiply the middle terms, they're going to cancel. And negative 1 times positive 1 is going to be negative 1. Now in the denominator, we're not going to multiply those. We're going to leave those just as separate terms. So x times root x plus 1 plus 1. Now somehow I have to get rid of this x because this x is not allowing me to substitute 0 in the denominator. So if I simplify up top, I'm going to get the limit as x approaches 0. Well, the 1 and the negative 1 cancel. So I have x over x times square root of x plus 1 plus 1. So now these x's cancel, and I'm really left with a 1 up here. Now I can use direct substitution, so I'm going to get the square root of 0 plus 1 plus 1, and this is going to equal 1/2. Okay, in our next example, I want you to pause the video and see if you can try this one on your own. Okay, hopefully you've had a chance to try this one. And again, you can see that I have a binomial radical up here. So if I use direct substitution, I get the square root of 9, which is 3 minus 3 is 0, and 6 minus 6 is 0. So again, my strategy is I'm going to multiply by the conjugate. Again, the conjugate, all we're doing is we're changing this sign. Okay, so now we're just going to FOIL out our conjugates. Root 3 plus r times root 3 plus r is going to be 3 plus r. Again, the middle terms will cancel, and negative 3 times positive 3 is going to be negative 9. And again, we said do not multiply out the non-conjugates, just leave those as separate factors. Again, why am I doing that? Because somehow I have to get rid of this r minus 6, because plugging 6 in there results in 0. So if we take a look at the numerator, I collect like terms. Again, this should be an r. I apologize for that. So on top, I'm going to have r minus 6 over r minus 6 times the square root of 3 plus r plus 3. Now my r minus 6's cancel. I'm left with a 1 up there. It's going to be 1 over. I can substitute in a 6 for r. And this works out to be the square root of 9, which is going to be 3 plus 3, which works out to be 1/6. So again, multiplying by the conjugate is an easy kind of question to see because you're going to have a binomial that has a radical contained in it. Okay, so that ends the second part of evaluating limits algebraically. So there's some questions for you to try. Give those a whirl and see how you do.